So it's always a little bit scary following Morton this early in a conference, because I never know what he's going to give away, what he's going to tell you about that I've already prepared 6 PowerPoint slides for. As it turns out, there's not been a great deal of overlap, so that's handy. So, this is the title of what I want to talk about. I toyed around with other titles. I really wanted to call this something else we should have done years ago. .NET Core was released, .NET Core 1 was released in 2016. Okay, so years ago pretty much just means 2 or 3. We're not ridiculously late coming to the spending the time looking at the .NET Core stuff. In the end, I ended up with the subtitle, .NET is dead, long live .NET, because as Morton mentioned in one of his slides, and I'll just gloss over this very much now, Microsoft at the moment have 2 very distinct versions of .NET things. They have the .NET Framework and they have the .NET Core. And as Morton said, with .NET 5, basically, they're coming together. Or at least maybe it's not even coming together. The framework's going away. I'm going to be left with something that's built from the .NET Core framework all the way up. The .NET Framework itself is not really going to see any further development, although, of course, there will still be fixes to it and support. And it, you know, as is often the case with all of these frameworks, people will still be using that 10 years from now with legacy systems and so on. But it's important that we move on and start using the .NET Core from Dyalog APL. So we'll need to investigate the feasibility of a .NET Core bridge. And there's a number of reasons for doing this, not least of all because we have to. Come 2020, when .NET 5 comes out, you guys are going to want to use that. We're going to need a bridge to allow you to use that. It's also portable, as Morton mentioned. The .NET Core is available on Windows, Linux, and Mac OS, which is 3 of our main platforms. So it would be useful to get the tools there. It's also open source, which is very handy. I'm always in 2 minds about open source. It's reassuring to know that the source code is there if you want to look at it, but as yet I've never wanted to look at any of it. And I've also never felt obliged to fix anyone else's code, even though it's open source. I'll still log a bug against something and expect someone else to fix it. So the open source for me is a bit of a red herring, but it's reassuring to know that if you want to figure out how something works, you can look at the source code and figure it out. The surprising thing, as I was doing the development with the .NET Core bridge, was how much code we had in our bridge and how much code that one could use from APL that was straightforward compatible between .NET Framework and .NET Core. So, broadly speaking, if you know what you can do with our .NET Framework bridge now, you might as well just go away for half an hour and come back later. There may be one surprise in this presentation, and quite possibly the worst segue that I've ever made in a conference presentation. But really, there's no surprises happening here. Let me start off, though, for those of you that haven't used the .NET Framework stuff for a while, let me just start off with a quick recap of things that we can do with the .NET Bridge. This is my Windows session, so I've got some scripts that I'm just going to run. So the .NET Framework is comprised of a bunch of assemblies, dynamic libraries that we can reference from the interpreter. We have a system variable called quad using, which basically tells the interpreter what we want to use. A single element like this pretty much means we want to have access to everything that's within the .NET, within the default libraries in the .NET Framework. So here, for example, I can access a date-time object. If I set my using to a non-empty value, that says I want to use the system namespace, which means I don't need to type system all the time. I can just elide that bit and the interpreter still knows how to find the date time. I can parse a string to generate a date time. Functions in .NET Framework have a lot of overloads. And something that we did quite late with the .NET Bridge was we added the display form of .NET functions to list all of the overloads so that you can see what those functions are. Let me make this window a little bit bigger. Okay. We can we can create arrays of date times. We can get the year for each of the dates in the array. We get autocomplete on our date time, so we can add hours to each of the dates, and so on and so forth. We can access the file system, we can access the environment, we can generate a list of all of the files that are in our temp directory, all through the .NET Framework, and we can get a list of all of the .NET assemblies that are loaded into our process. So that's a brief recap, a summary of .NET stuff that we've been doing for, as Morten says, 20 years. We can find out what machine we're running on. But what they're telling us with the .NET Core is that this now, if we have a .NET Core bridge, should all be portable. Which means that, is this my water or is this? This is mine. There. Which means that in theory, if they're not lying to us, we could switch to a Mac desktop. Here we've got a version 18 with Ride on the Mac. And if the .NET Core is as portable as they tell us it should be, we ought to be able to, on our Mac, in a clear workspace, say we want to use the .NET framework and say we want to create an instance of a system date time object. We might say, well, I don't want to type system all the time, so we'll inline that by setting quad using. We'll do the now, we'll parse a date time. We'll look at the display form of all the overloads of the parse thing. You're paying way too much attention. We can create vectors of date times. We can have autocomplete on our dates, so we can add 1 year to each of our date times. We can access the file system. We can list all of the files in our temporary directory. And we can list all of the assemblies that are loaded into the process. So if it was portable, we'd be able to do things like that. And we can find out what we're running on there. So the key, is there a? No. Okay, so the important thing here, look, it says we are running on JD's MacBook Pro. The operating system is a Unix version 18, and this here is telling us, no surprises now. Even this isn't a surprise given the title of the presentation. We're running version 3.0, so this is .NET Core 3. Preview 8, which I'm using now, they released Preview 9 on Thursday, I think. And had I been a little bit more on the ball, I might have updated to that. I know an hour ago, but it would seem a bit risky. So, yeah, so it looks like it works. Is it portable? It looks like it might be a little bit portable, so that's sort of handy. So anyway, so we needed to write this new bridge. So I'll give you a little bit of a history of the transition. It's not a transition, it's a completely starting from scratch. The framework bridge that we have is comprised of approximately 1,000 lines of C# and 20,000 lines of C++. And was developed primarily with, any guesses? Shout them out. What would you reckon we developed the .NET bridge with? VI. Of course. Why would you use it? We might have not used VI for the debugging, but the code writing and all of the development was done in VI. It's time to move on a little bit. So the new bridge is predominantly now written in C#. Okay, and the process is essentially taking the C++ code that we have in the original bridge, cutting and pasting it into the development environment for the C#, looking at it very closely to make sure it's all doing what it should be doing, taking advantage of the greater power that we have in C# to do things in a better way, and always with that view of what can we do better, what have we learned over the past 30 years, what can we optimize, what can we improve, what can be better. So the new .NET Core bridge is primarily developed in, any guesses? It's not VI, no. No. I mean, they're all great ideas, and to be fair, I still have typed VI, and in fact, my VI actually on my machine is an alias to Vim anyway. So it's the same thing. No, so it's developed in Visual Studio Code. But so we chose C# because it's portable, at least on the platforms that we want to run the bridge on. It's very powerful. The tooling for it is great. It's cool, not a great idea, but it's nice to be one of those. It's nice to feel young again and using the cool tools that all the kids are using. Why Visual Studio Code? Because it also is portable. You can run Visual Studio Code on each of Windows, Linux, and Mac OS. So where we want to run it is also where we can develop it. It's powerful. We'll steal some ideas from there. It is the great tooling that C# uses, so that's great. It's cool, and it's got some wonderful extensions. So C#, Visual Studio Code, all of a sudden, we're bang up to date. It's brilliant. So it would be fair to say now that .NET Core is my main squeeze. It's my thing at the moment. Bad segue. Speaking of squeezing things, let's talk about zipping files. So, if we wanted to zip files on our Windows machine, we have choices. We could just quad CMD out to zip.exe, but of course that's not portable. You might not have zip.exe installed on the machine. We could, and we'd also have to create the file, for example, readme.txt, put some text in it, zip it up to create our zip file. There are functions we could use via Quad NA on Windows to access the Windows compression APIs, but it's too difficult, life's too short, and also not portable. We could use, now we've got a .NET Core Bridge, we could use the zip archive that is part of .NET. A little drop down here tells me, this says it's available in .NET 4, Framework 4.8, but we can also see if we move here that it's also available in 3.0 Preview 9. Always scary, the implication not in Preview 8, but worry not. I've been through that scary process for you. Don't worry about it. So what we can do, I'm just going to scroll down a little bit here, then is we can now, with our .NET Core, play with that class. So a little bit of housekeeping. What I've got on this machine is, this is a Mac. This is a Windows VM running on the Mac. So what I've got here is our directory, which is mounted on the Windows machine, but actually it's a directory that's on the Mac. It's just convenient for me to have all my demo stuff in one drive on the machine. I'm going to copy from a workspace a function called zip, and here is that function called zip. I'll try and make this bigger. Now, it's not very APL-y. What it is very .NET-y. In fact, if we go back to the web page that I was on, oh no, not that. Oh, don't give that away. You didn't see that, right? If we look at this C# example here, that is pretty much exactly what the APL zip function is doing. I've just transitioned it from C# in that example to APL. But basically what we do is, what we've seen is we initialize our quad using, we make sure that the directory exists that we want to put the zip file into, we create a new file stream, from that file stream we create a zip archive, we then create in that archive an entry called readme.txt. So this is going to be the name of a file in the zip archive. We're not going to make this file readme.txt on the disk, we're just going to insert it directly into the zip file from data in the workspace. Okay, so we don't need to do that extra process of inputting anything into this thing called readme.txt. And then we're going to write our left argument message into the zip file, and I'm also going to append the current timestamp onto that message so that you guys know that I'm not cheating and I'm not just doing a bunch of things with zip files that I did earlier this morning. Question, Kai? I will repeat it if you ask one. What is? Right, okay, so colon disposable is a okay, so many .NET objects may have unmanaged resources that they are keeping hold of. Okay, with garbage collection, you never know when those unmanaged resources may be released, okay, because garbage collection may happen half an hour or 3 days in the future. Okay, because these things are opening files on the operating system, we need a stricter way of managing their life cycle. And what colon disposable says is when we get to the matching end for the colon disposable, the interpreter makes calls to whatever object is in the right-hand side of the colon disposable statement, telling it that it can now dispose of any unmanaged resources that it is using. It is equivalent to the I don't know how to make this font bigger. It's equivalent to the using statement that we have here in the C#, which is doing exactly the same. Oh, that's good, isn't it? Oh, yeah, sorry, it scrolled. That's why. It's equivalent to this using statement here. So basically it says, for the duration of this section of code, I'm going to be using this stream writer. At the end of it, you can dispose of its unmanaged resources. It's been in Dyalog for a while. It's a useful thing. Under the covers, it basically implements or executes the iDisposable.dispose method of the .NET class. Sorry? Because localizing it only takes the name out of scope in the workspace or in the program, it doesn't ensure that garbage collection happens immediately. And if the unmanaged resources are only closed when garbage collection occurs, that may happen at an unpredictable time in the future.
It's not APL workspace.
Oh, yeah, sorry, it's .NET garbage collection, not APL. Right, who knows how to close this? Because I tell you, because if I... Windows, I haven't got, if I had a Windows keyboard, that'd be, Panic not. I'm on the case, I've been using Windows for 30 years. How satisfied am I with Magnify? Shall we answer? Do we want to? Anyway, okay, so let's get back to that. So that's our .NET-y zip thing. So what we can do is we can say, okay, I'm going to create a file called demo1.zip. I'm going to put the hello world exclamation mark in there. We can now see that in that directory, I've got that one file. I can open that file in Windows Explorer just to prove that it's a zip file like any other. There's the readme.txt in the zip file. Double click on that. And there's our text. Control plus, let's try that. APL keyboards. Okay, so 999, that's today, isn't it? 9:56. Which is what the time on my machine says, but it's not. That's not the time, is it? Well, it's funny, isn't it, when things don't work? I'm going to fix this because a lot of these messages are going to have timestamps on, and the whole point of doing that was so that it was the correct time to prove that I wasn't doing anything silly. And so I've got 10:16, so let's do that. 10. It is 10:15, isn't it? Yeah. Okay. Yeah, you know. So we're not going to save that. We're going to close that. Okay, so that's our zip file. We could unzip it on Windows. Not going to unzip it on Windows. I'm going to unzip it on the Mac. Okay, so on the Mac, I can now copy the same demo function. So on the Mac, this directory reference here, it's the same directory. It's got the same files in it. Here is our unzip function. Okay, which is sort of just doing the inverse of what we did in the zip. It's enumerating through all of the entries in the .NET archive, and then it's just reading to the end of that stream to get the content back out again. So we can unzip, and there's our hello world, which we put in that file in 9:56. Again, it's not written that readme.txt file to the disk. It's just extracted within the application the data that was in the files that were in the zip archive. So we can go back to Windows. We can ask, how is it going so far? Zip that into demo 2. Unzip demo 2 on the Mac. How's it going so far with 10:17, which is now the correct time? We don't want to keep zipping between the two machines just to unzip a file when we created a zip file. Let's look at the file system watcher that we have in .NET Core. So here we have a function. The font's okay, is it, for everybody? I've tried to make it reasonably sized. So, sorry? I can push it. Okay, you're gonna see less, but there's nothing to see here. There's no surprises here. So what we're doing here is we are going to create. This is the Mac. Remember, we're on the Mac. The desktop is a nice flowery thing. It's a Mac. The Windows desktop's got a horrible, gaudy, Microsoft-y, Windows-y desktop. We're on the Mac. We're going to create an instance of the file system watcher object, tell it that we want to watch the directory that we're passing as an argument. We're going to have callbacks as files are created and changed. We're going to specify a wildcard of files that we want to watch, which is in the left argument, and we're going to enable watching the events on the thing. We've got a callback on created, which is just going to spit out a couple of words into the session. We've got a callback on changed, which has got an error in it. So I'm now going to create that file system watcher. I'm now going to go back to my Windows machine, and I'm going to create another zip file. Now, watch this. Okay, so we now got a suspension on the Mac because it has detected that a file has been changed on the network drive that's being shared between the two machines. We can, there's the file name. We can unzip the file. Now watch this, 1018. It seems about, I'm not lying to you, wouldn't lie to you. You're cleverer than that, you'd notice. So what I'm going to do is I'm going to modify this file, this function, sorry, so that rather than just spitting things out, I'm going to unzip stuff. And I'm also just going to edit the created function. I'm just going to comment that out because it's not particularly interesting anymore. So now we can carry on. We can now move back to Windows. We can watch something else. Okay, we haven't got the error anymore, but when we come back to the Mac, we can see that we've got this watch this again, which is from the message that I've just created on the Windows machine. There are a few glitches here. They're not mine, they're .NET Core glitches, or maybe they're just accurately representing what's going on. We've got two messages here. This file was changed twice. And if we were going to do anything significant with this file, we might want to be aware of that as we were watching it. But, you know, seems to be reasonably portable. Let's load another couple of functions onto the Mac using the .NET Core framework. I've got a function here called send. What this uses is a .NET Core package that I downloaded from GitHub. Because Microsoft told me to do so, I Googled for how do I send emails from .NET Core. The Microsoft documentation had an implementation. It said, this is deprecated. We recommend that you use this one on GitHub. Okay, so there's a lot of open sourciness going on. There's a lot of Microsoft taking this open sourcey stuff quite seriously. So what we have here, we won't go into the details, but it's going to create a mail message. It's going to put a subject in it. It's going to send it from somebody to somebody else. It's going to authenticate on my account. That's just a one-line function, but I don't want to show you my username and password. And it's going to send an email. So we could, for example, do send I am spam, please buy my stuff. The machine will beep because it will get an email. The machine will beep because it will get an email, as long as I'm still connected to the internet. Well, that's slightly annoying. Well, okay, so there's my email client. There is the message, which I sent at 10:22. It says, I am spam. And it says, please buy my XYZ, sent from the name of this machine. I'm not sure why I didn't get the beep, and I'm not sure why I didn't get the notification. Maybe, as we move on, we'll start getting those. I did when I was sat there an hour ago. It should be, but I should be getting a little toast notification as well. So now I'm going to edit my changed thing. I'm going to say, when a file is changed, I'm going to send an email to jddemo@dialog.com. Send, and I'm going to disclose that because unzip actually returns a vector with one element per file within the zip file. So we're going to fix that. We're going to go back to Windows. We are going to... Oh, no, we've done that already. We're going to ask to be notified when a file gets zipped. Or, sorry, when the Mac detects that a file has been created on the shared drive, it's going to unzip it, it's going to send me an email. Hopefully, it should beep, and I should get a little toast notification here, which it hasn't done, but we do see that in my email client, I've got these things that say notify me, sent from JD's MacBook Pro, and the timestamp is 10:24. That's when the email was sent. Do this again. Notify me again. Beep! Do you hear it? And there's my notify again messages in the email. Okay, so we can do the file system watchery stuff. We can send emails, all using .NET Core. All of these functions work interchangeably on the Windows machine, on the Mac. They're just using .NET Core. It's the same workspace. I could have done this exactly the other way around. It all just works. Now, where am I supposed to be? Am I supposed to be here or am I supposed to be here? Who's keeping up? Oh, back to the Mac. There you go. It's helpful. Okay, so here's another thing that I'll set up now. We'll come back to this later. This directory here is where all of my source codes are for my development environment on the Mac. I'm going, and okay, here's some interesting statistics. In my development tree on the Mac, I have 120,000 files, approximately, and about 13,000, 14,000 directories. Okay, I've got a slightly modified version of this watch callback. What I'm going to do is I'm going to watch for star.dialog files in that directory tree. So I'm going to enable the including of subdirectories in my file system watcher, and I've got two subtly different callbacks. One's that's going to tell me that a file has been created, and the other one is going to tell me via email that a file has been deleted. So we will switch the old file system watcher off, switch this one on that source directory, and we will then forget conveniently that we've done that. So Microsoft will tell us that this stuff is portable. We've run it on Windows, we've run it on the Mac. If I now control left rather than control right on my keyboard, we're on a Linux machine. And this is a Ubuntu something or other Linux machine. But we can do all of this .NET-y stuff on the Linux machine. Okay. This Linux machine is already running a file system watcher listening for zip files in that shared folder. Now, again, there's another little glitch here in that it hasn't been sending us emails. Okay. I don't know why that is, but if I come to the directory where all of those zip files are, they're all dated. You see the time's wrong on this machine as well. It still thinks it's 9 something in the morning. September the 9th. I was either doing this live now, or I was very rudely doing this when Morton and Gitta were talking earlier this morning. It's all live, it's all now. But if I touch one of these, okay, pretend this should have happened automatically. I don't know why it didn't. But then the file system watcher on the Linux interpreter kicks in using its .NET Core bridge. And if we come all the way back over to my email client, we've now got a message that this email was sent from the JD Linux box. Okay, so, is it portable? It looks like it might be. Right, so, surprise time. It's not. I've always been a child. I gave a presentation 3 years ago about airfix models. Okay, if things go according to plan, next year I'm going to give a presentation about building things from Lego. That's the plan. Might work, might not work. Don't hold me to it. But today, now, for this project, I'm going to be a grown-up. I'm going to test. I don't like writing tests. There's nothing creative about writing tests, or so I thought. Okay. Tests are a lot of fun. Inside the interpreter, we have quite a slick way of testing bits and pieces of the interpreter. Okay, we have a lot of single-line unit tests in the interpreter source codes. Okay, if we go through our interpreter source codes, we can find a lot of, interspersed with the C code, we can see these statements which are, they're basically comments in the C code, but they begin with delts. And these are all one-line tests. And what happens is, as part of our overnight process, grabs all of these one-line tests out of the interpreter and executes them. And the nice thing about these is that the tests are really bang adjacent to the bit of C code that they're testing. Really useful, really slick, very handy, and a very lightweight way of making sure that we put tests in for stuff when we need to. Now with the .NET Bridge, it's inserting APL code into the C# and going through that process of grepping it all out. It doesn't seem very feasible to me. So we need another way of getting the test adjacency for the code with the .NET Core bridge. So let's come back to the Windows machine. So what I've got is a tests workspace that contains two very simple functions. Okay, one of them, called run, just fixes a .dialog file which is in the same part of my SVN repository as the .NET Core Bridge code itself. Okay, and then the other function just fixes it and runs this thing called run all tests, which was in that script. Okay, and we run this. Oh. Now, well, yes, but it doesn't help my script. Let me just go through and see what's going on. Wow. Why is this not doing the same thing? This is not how I suggest you write your tests. Wow. Wow, this. Well, no, because I modified the. Oh, yeah, probably. So what's in R at this point? Yeah, let's just. I mean, this is quite annoying because you know what it is when you're doing a demonstration in a few days. You do nothing but test it and run it over and over again. You know, in the same room, on the same computer, the same internet Wi-Fi connection. It's people. Anyway, okay, so we run, we get a 1 back, tests work, that's brilliant, that's great. Okay, so I've written a test that can return a scale of 1, and I'm even lying about it. But this isn't really how we want to test it. What we want to be able to run our tests from within our development environment when we are working on the core bridge. So this is Visual Studio Code. Okay, this is the layout of the project. There's a bunch of C Sharp in here, okay, which is the .NET Core Bridge. There's a little bit of native C++, but that's not interesting. We won't look at that. There's a folder here called tests, and here we've got this testtools.dialog file, which is the file that I said the workspace was basically bootstrapping everything from. Morten mentioned this stuff before, which is actually very convenient. What we've got here is an APL plugin for Visual Studio Code, which was developed, I think, by Gil. Okay, it gives me syntax coloring for APL. It gives me autocomplete for APL. Very, very useful. Okay. So this .dialog file just contains a bunch of very simple couple of functions just to bootstrap the whole process. What I have here is I have a bunch of .dialog files containing specific tests for specific parts of the .NET Bridge. Okay, and this is the code that it's testing. These are the tests that I'm writing. The adjacency of my tests is much higher than it was before. And what I can do, again, this might... Okay, and so the way the thing's set up at the moment is if one of the QAs, if one of the tests fails, it suspends in the interpreter so I can figure out what's going on. If I was running this normally automated, then it wouldn't do that, and it would just say the test didn't work. But what I can do now is with a couple of keystrokes, I can now run that entire process from within Visual Studio Code. And on top of that, I can get code coverage of all of the C# that's in the .NET Core. So quick poll, what was a good result? A good percentage for code coverage? What would be good? What's acceptable? 50? 50%'s good? Okay. Anyone want to say that's crazy, you could never do 50? Anyone want to say 50 is not really encouraging anything? Pick numbers? Anyone? Bob?
Software Works believes it's 93.
93, okay. So assuming that my tests are going to work and not suspend, then let's just run them. Control-Alt-T. Oh, I think I can also zoom, make this stuff bigger too. So it's now running my tests. Oh, right, yes, I need to do a paren off from here because actually also what it does is it does a build. And that build's not going to work if the thing's already loaded into. So okay, so starting the tests, we may get that error again. I don't know what that error came from. Okay, so here we are. So I'm getting 99.73% code coverage on my .NET Core code. Okay, there's about 2,500 lines of C#. Within this tool, I can press this watch button here, and then I can navigate through all of my code, and I get green lines through all of the code that is hit by the tests, and I get stuff in the gutter that's my entire file. Everything that's green is a line of code that's been hit by a test. Anything that's red is a line of code that hasn't been hit by a test. Okay? Yeah, well, we'll talk about that. There's gaps in here where there's code where I have intentionally if falsed it out, so it's not even compiled, so it's not included in the test. But we can go through all of the source files here, and we can see nice green everywhere, no red. However, there's some red here. Here's a bit of code not being tested. This is the code that loads .NET assemblies when we use quad using and we say, I want to load this assembly. And clearly, I'm missing a test that says, but what if that doesn't work? And this bit of code hasn't been hit by the code coverage. So what I'm going to do is I'm going to come over to my scripts. I'm going to create a new assemblies.dialog file, okay, which gets me into the editor. Now, I've got some code snippets that I've written. So I've got one that's called :test, which gives me a generic framework for one of my tests. I'm going to call this one assemblies. Okay, so it's a namespace. It contains a variable that says what functions it should run, and it contains the function that's going to run. It's got a bit of bootstrapping around it. It returns a Boolean vector. If there are any zeros in it, your test hasn't worked. So this basically is a no-op, but there's no zeros in it, so it's going to work. I'm going to insert now into here an actual test, which is going to try and quad use an assembly that I know doesn't exist. Okay, I'm now going to just hit Control-Alt-T again, run my tests again. And we get 100% code coverage, 100% branch coverage. So not only are we hitting 100% of the lines of code, where there is a line of code that says, if this, do this, otherwise do that, we're hitting both the if and the else part of that. Now, I don't know what this means. It doesn't tell me that everything works. Okay? It tells me, I think I know two things. Because the test succeeded and I got a 1 back, that means that everything that I'm specifically testing for has generated the expected, but still possibly not the correct result, but it's the one that I coded in the test. So I'm reasonably confident that everything's returning the same results that they returned when I thought they were good results. Okay. It sort of tells me that I haven't got any redundant code. I've not written any code that I don't know how to call. So that's good. But it doesn't really tell me that all of the code is correct. It just tells me that it's not wrong. No, it doesn't. It tells me that I don't know what it tells me. What I do know is that it gives me a warm, fuzzy feeling inside. What I know is if I change something if I change the code or I write some new code, first of all, I'm going to get some more red lines, so I'm going to need to write some more tests. That's a good thing to be told to do at the time that you write code. Okay. The second thing I know is that if I change something, I will know that I haven't broken something that used to work, and that's nice. But it doesn't mean that it's all right and I can ship it and it's finished and it all works. But it feels good. So that's testing. It's good, isn't it? I'm a grown-up. And the advantage is, as close as I can manufacture it, the tests are now adjacent to the code that they are trying to test. Right, so they tell us it's portable. There's a little I in here. I like this. It's Pi-portable. Let's move over to this machine. So let me connect to a Raspberry Pi that's running in the Dyalog office. Okay, excuse the junk as we get the junk. So here we are on a Raspberry Pi. On my Raspberry Pi, I can do quad using gets quote. I can do system. I'm not running RIDE here, so I don't get any autocomplete. This is just a TTY interpreter running on the Raspberry Pi over an SSH session. So there's no RIDE, there's no GUI. But it's just a, where we were on Linux is 5 years ago maybe. We can do this. We can find out what time the Raspberry Pi thinks it is. A little slow the first time because it's got to load some libraries up. I can load my tests workspace. I can run my run script. Okay, I get a 1 back. They're not the fastest machines in the world, these Raspberry Pis. But hopefully, I get a 1 back. So I know that on the Raspberry Pi, all my tests have worked. I know that when I run my tests, I run all of the code. So I know that when I run this on the Raspberry Pi, everything that I did on all the other platforms works on the Raspberry Pi. It's warming. It's like a good drink. So yes, seems like it's portable. So that's good. So that's where we're at. Okay, bunch of stuff works. What's important is to realize is that the .NET Bridge doesn't know about sending mails. It doesn't know about zipping stuff. They're just objects and functions that it knows how to call in a very generic fashion. Okay, so I know that I can manipulate functions that take strings, and I know I can manipulate functions that take strings and numbers, or functions that return and take objects as arguments. The fact that they're mail messages, the bridge doesn't know anything about that. Okay, that's your APL code that's providing that specificness. There's a better word for that. The bridge is a very generic thing. Okay, but that's where we're at. There are a number of things missing. Let's talk about that. I mean, to be fair, there's lots of things missing. Okay, but the important ones that I think it's worth pointing out is there's no GUI support in .NET Core yet. There's certainly not any in our bridge. I mean, maybe some things we need to do. Microsoft tell us that WPF is going to be supported in .NET Core. I'm not sure if they've said that for 3 or for 5, but there will be GUI support coming to .NET Core in the future. So these are the things that I've identified as missing things. Okay, there's no .NET Core for AIX, unfortunately. Okay. I'm personally hoping that we don't need to produce a classic version of the .NET Core bridge. So if any of you desperately want this and are running classic interpreters, then come and talk to us, because I'm not in a position to make that decision anyway. But it's an extra level of complexity that, because we're sort of starting again, it might be nice to get away from. At the moment, we can't load both the framework bridge and the core bridge into an interpreter at the same time. I'm hoping to resolve that before 18 comes out, because it would be nice to be able to piecemeal bring utilities in that use core while your main workspace uses the framework stuff. At the moment, we can't export any APL classes so that they can be consumed by .NET Core, but we'll come to that. And obviously, over a period of time, we're hoping that Microsoft will produce the GUI, and we're hoping that, well, and certainly we will go through those lots of things that are missing from the old implementation and bring them across into the .NET Core bridge. There are a bunch of specific things that now might be a good time for us to tweak and to change. And we've got 25 years of experience with the, not 25, why am I saying 25? We've got 17 years of experience with the framework bridge. There are a number of things that in there that I know aren't ideal, and I'm sure there are lots of things that those of you that have used it will be aware of that are a little bit clunky and that maybe you would like to see us change them. A few examples, we're not very good at supporting generics or nullables of type T. If this doesn't mean anything to you, then that's great. If it means anything to you, then you can tell me whether things need to be changed or not. C# now has optional name parameters to functions in addition to the overload mechanism that it's currently got, so maybe we ought to do better with that. We could do better with quad using, perhaps. We can incorporate more DWA extensibility into this, which means you can extend it yourselves to manipulate your own types. Async and await is something that would be really good to get in here. Every time I think about it, it makes my head hurt. So I need to go around that loop a few more times to know exactly what we may or may not be able to do. But generally, if there's stuff about the existing framework bridge that is always slightly jarred, you've always found a little bit annoying, why do I have to do this, why isn't this easier, then do let us know, because we might not be able to change that bridge, but we can probably make this new bridge a lot better. On that note, I've got about 1 minute for questions, if there are any. Please do come to the front, though, so that we can record the thing on the microphone. If there aren't any, I'll take it just because there was no surprises and everything did what everyone expected it to do, and that's good. Brill. All right, well, thank you. It's coffee now. We'll be back in 30 minutes.